Welcome to physics class. In continuation with our lesson on electricity, current electricity, we need to learn how to use Ohm's law to do calculation in current electricity, and also how to resolve circuits, resistances in circuits, both in series and parallel. We need to know how to resolve it. By this video, we'll be able to understand fully how these are done, how to resolve resistances in series and parallel, and also how to do calculation using or applying Ohm's law. So that is the intention of having this video, this class. So starting by the first question we have here, it says that a battery of EMF 8 volts and internal resistance 1.0 ohms is connected to an external circuit as shown below. Find the value of current flowing in the circuit. So with this problem, to solve this problem, we have to first of all resolve the resistances that are connected both in series and parallel. We have to resolve it to have the effective value of the resistance in the circuit before proceeding to calculate the current. So solution: we start with resolving the resistance in parallel. You can see current flows through this from here, getting to this end. When it gets to this junction, it splits into two branches. That shows that this and this arm and this arm are in parallel. So we have to start by resolving this 100 ohms and 50 ohms resistors that are connected in this, which are in parallel. So to resolve it, since there are two resistors in parallel, so we have to find the effective value of the resistance in parallel. Resistances in parallel. Rp is equal to the 100 times 50 over 100 plus 50, and that will give us 100 times 50 divided by 150, of which 0 cancels itself and cancels 0 here, and 5 cancels itself 1, and here to give us 3. So that gives us 100 over 3. So R P is 100 over 3. So continuing with that, we have to find the R total. R total will be in series. That is what we have resolved here, which gave us 100 over 3 plus this one. So this and what is coming out from here will now be in series, and that will be 80 plus 103, 100 over 3, sorry, and that will give us 3 down there. 3 into 3 will give us 1 into times 100 will give us 100. 3 into 1 will give us 3 times 80 will give us 240 which will give us 340 over 3. So that is in ohms. Our total is 340 over 3 ohms. So moving ahead, this can be equal to 113.3 ohms. So we are given, from the question, we are given that the resistance, internal resistance R is equal to 1 ohm, and we are given that, we are also given that the EMF is equal to 8.0 volts. So using the formula I equal to EMF over total external resistance plus internal resistance, and substituting the values, we have 8 over 113.3 plus 1, which gives us 8 over 114.3. So 8 over 114.3. We use our calculator. 8 divided by 114.3 is equal to, so we're going to have current to be equal to 0.069, or approximately 0.07 amperes. So that is the value of the current flowing through the circuit. Moving ahead to the next question. Question says, resolve the circuit diagram below to determine the effective resistance in this circuit. So as we can see from the circuit diagram, we want to find the effective resistance in the circuit. The resistances we have, starting from here, we have this, that, and that. So up to 1, 2, 3, 4, 5, 6 resistances connected in both parallel and in series. So we need to know what to do to resolve, to find the total or effective resistance in the circuit. So we start by trying to determine the value of the resistance in parallel between this and that. That is 6 ohm resistor and 12 ohm resistor. So we have to determine their effective value. Solution. So we have R parallel sub 1 is equal to 6 times 12 over 6 plus 12, which gives us 6 times 12 over 18, and 6 can cancel itself, 1 and cancel 18 to give us 3, and 3 cancels itself, 1 and into 12 to give us 4. So what we have here is 4 ohms. So having found that, the effective value of this and this we combine to be in series. So we find their total value, that is R series 1 will be 4 ohms plus 2 ohms, which will give us 6 ohms. So having found that, we have resolved everything within here. So that means we have a single resistor coming out from here, which is 6 ohms. Effective value of single resistor from here, this column is 6 ohms. So combining it with this, that will be in parallel. These two now are in parallel. So we say that R parallel 2 will be 3 plus 6. For parallel, for two resistors in parallel, that will be 3 times 6 divided by 3 plus 6, and that will give us 3 times 6 divided by 9. 3 cancels itself 1, and this to give us 3, and 3 cancels itself 1, and this to give us 2. So we have 2 ohms. So having found that, we have resolved what we have here within here. So the effective resistance now will be in series, because this and this combines to give us one resistance, and that is 2 ohms. It has a value of 2 ohms. So moving ahead, we have resolved resistance in series. R series 2 will be equal to 4 plus 2 plus 1. 4 plus 2 plus 1, and that gives us 7 ohms. So having found that to be 7 ohms, okay, that's exactly what we are asked to find. We are asked to find the effective resistance in the circuit. So that is 7 ohms.